Dr. Evil is in his elegant lair, busily hatching another especially evil plot. This time, he's after some information stored on General Good's computer. To steal the data, he plans to use Cheese 1, a computer hacking drone. Before Dr. Evil can launch his plan, there are some problems he must solve. Cheese 1 can copy data at a speed of 1.25 petabytes per second. Dr. Evil has been surveying General Good and knows that every day, exactly at midnight, General Good opens the window and goes into the hallway to stretch for 60 seconds. So the drone will have just 60 seconds to download all of the data. The problem is, can Cheese 1 complete the task in time? You may ask, how can Dr. Evil solve this problem? He can graph linear equations using slope-intercept form. Let's take a look at the coordinate system. The file he plans to steal is 90 petabytes. The drone has exactly 60 seconds to copy all of the data, and the hacking program loaded on Cheese 1 takes up 15 petabytes of space. The drone will have a total of 105 petabytes of data after copying the wanted files if the caper is successful. Now he writes the equation in slope-intercept form. Y is equal to mx plus b. Remember, m is equal to the slope and b is equal to the y-intercept. For this equation, x represents the number of seconds it takes for the drone to download the data, and y represents the total amount of data stored on the drone. The drone can download 1.25 petabytes of data per second, so the coefficient, or the slope, of x is 1.25. The hacking program loaded on Cheese 1 takes up 15 petabytes of space. Since this number does not change, it's called a constant. It is also the y-intercept. Putting all of this together, the equation in slope-intercept form is y equals 1.25x plus 15. Dr. Evil graphs the equation. The line touches the y-axis at the y-intercept, 15. The slope is 1.25. To graph this, write this decimal as a fraction. So the slope is 5 over 4, which means that the line rises 5 and runs 4. Dr. Evil needs to know if Cheese 1 can do the task. Oh no! The line doesn't go through the ordered pair of 60, 105, representing 60 seconds and 105 petabytes, respectively. Cheese 1 is too slow. What can Dr. Evil do? Dr. Evil has a plan B. He can use Mach 2, a faster version. It's a bit of a risk because Mach 2 is a beta version, but Dr. Evil is desperate. Mach 2 has a download speed of 1.75 petabytes per second. Using the download speed for Mach 2, Dr. Evil writes a new equation in slope-intercept form. This time, the x coefficient, or slope, is equal to 1.75. The y-intercept does not change. Dr. Evil gathers his evil data and draws an evil graph. The line still touches the y-axis at 15. But since the slope is 1.75, or 7 over 4 in fraction form, the line rises 7 and runs 4. The graph indicates Mach 2 can download 120 petabytes of data in 60 seconds. Dr. Evil is ecstatic. The graph shows Mach 2 can do the task with seconds to spare. Dr. Evil can't wait to take a look at the data stolen from General Good. Oh no. What's this? Mach 2 copied the wrong file. Now Dr. Evil's computer is infected with the kitty cat virus. Meow!